All right, so we are live right now. I hope I'm audible to all of you. Okay, so welcome back. Welcome to this amazing platform of Tutee Learning, JEE. So today we'll discuss about the important properties regarding the scalar triple product. So if you have watched the previous session or previous lecture, you must have seen that we have been discussing with the idea of scalar triple product, and following that we have been solving some question regarding the properties, as well as we have been seeing on how to solve different types of questions and using this particular idea of scalar triple product, right? So in today's session, we're going to do the same thing. We're going to discuss more on the properties. But before that, let me help you to understand that if we have a vector, if we have the three vectors which are given in the components, how do we compute the scalar triple product? So let's try to understand on that particular part. All right. So let's start. So let us say that we have the given vectors are given as follows in the component wise, like this, right? So let us say we have our a vector, b vector and c vector as follows, right? So if we need to compute the scalar triple product of these three vectors, then the result can be easily calculated as by following operation of this determinant will give you the following result, right? So this is very do that because we have seen that product actually implies, or it is basically a cross b dot with a dot b cross c. So if you try to compute, or if you remember that when we seen the definition of uh, vector cross product, we have learned to so when we were calculating b cross c, this can be given out simply by the I, j, k and b1, b2, b3, c1, c2, c3. Then if you take a dot product with a vector, the result will be simply given something like components as the genus of xk cap. So if these are the three vectors, so if these are your three vectors, then find x such that you have the c vector in the plane a vector and b vector. This problem and let me know the answer. So please take your time and try to solve this problem. This is a very simple problem. Please take your time and tell me the answer. All right. Of x. If you still have any question, please let me know in the live chat so that I can help you out with your questions. Please let me know your questions in the live chat. This is quite an important result. So it is very important to understand this result so that we can proceed for solving some questions. Okay. So please first of all try to interpret this result and try to solve and find the value of x. Try to find out the value of x. Alright, so let us try to see how we proceed to solve this question. So we can see that in order to find the value of x, the important result we need to utilize over here is that and 1 for the a vector, and for the b vector 1 minus 1 and 2, and for the c vector it is x minus 2 and minus of 1, and that should be equal to 0. Calculate the determinant, and from this particular determinant which is equal to 0, this will be minus 1 minus x value of the following expression, that is given as a dot b cross c, a dot b cross c cross with a vector plus b vector plus b vector plus c vector. So you have to find out or evaluate that expression. Try to solve this particular problem. Please try to solve this particular problem. Fairly interesting question. Where all right. So carefully look at carefully look at the expression. Okay. So please carefully note the expressions over there, and if you carefully look at the expressions, I think you'll be easily able to solve or carry out the problem, right? Vector b plus c vector and a vector plus b vector plus c vector, and these will be given in the scalar product, right? So this is the result. Very important to note that from this particular understanding. So let us try the results of the coplanarity concept. So if you recall the coplanarity test by using the simple basics of algebra of vectors, we have seen that if I have it is very important to understand this particular part so that we can proceed to different types of questions. Okay, so that's why I'm letting you know these are the simple problems with which you can start with, right? And once you understand these problems, then we can go on to study about the difficult part, right? So I hope this is clear to all of you. I hope the result is clear. All right. So if this part is clear, let's now proceed to understand about the other properties. So if this part is clear, let's now talk about some other properties. So let us continue with the properties. So if we continue the properties, the property number 6 talks about that if we have 4 points whose given position vectors are given as a vector, b vector and c vector are the position vectors. So PV stands for position vectors of 4 points. Alright, so PV stands for the position vectors of these 4 points. So if I have this 4 vectors at the position vector of the 4 points, then if I try to calculate b vector, d vector, b vector and c vector and take a box product of it or scalar product of it, the result can be added with d vector, c vector and a vector. The result is going to be equals to and one more addition, that is your d vector, a vector and b vector. So if you see over here, I have taken this b, c, ca and ab in a cyclic manner. So if I just add all the 3 results of the scalar product, then the result is going to be simply equal to a vector, b vector and c vector. I hope this result is clear. Alright, so this is a very important property and yet an interesting property, okay? Also, if you want, I can definitely give you the proof for this, okay? So the proof is yet very simple and effective to understand this result, as what you can see, if I give you the following results of vectors. So the four vectors are four vectors. Okay. So this is a very interesting and yet an effective part to understand. Okay, so we will try to apply these types of problems. The result says that, let us say I have small a, small b and small c are my three non-coplanar vectors. Okay, three non-coplanar vectors. Okay, let us say these are my three non-coplanar vectors, and such that I form capital X as x times of small a, y times of constant scalar integral product of this small a, b and c vectors. Of this small a, b and c vectors. Okay, so this is the result for the scalar integral product of the capital A vector. We calculate the scalar integral product or result of this capital A vector, B vector and C vector as a system of vectors, and L vector, M vector and N vector is another system of vectors. Okay, these are the two triad vector, B vector and C vector, and if we calculate the scalar integral product of it and take a square of it, this result can be simply given out as A dot A, A dot B, A dot C, similarly B dot A over here. So it's very important to note this particular formulation so that we can proceed to solve some questions. Alright, is this part clear? Is this clear to all of you? So if this part is clear, let's now talk about the last